delta y conversion, sometimes you will have some resistors that you cannot combine them. If you have some resistors which are not parallel and which are not in series, you can apply a delta y conversion to make them in parallel or in series. Consider the circuit I'm drawing. R1, R2, R3, R4, R5. That's the voltage source. Okay. For example, I want you to analyze that circuit. Can you see any combination? Can you make any combination in that circuit? Are there any serial connected or parallel connected resistors? No. Okay, they are neither in series nor in parallel. You can apply a technique which is called the delta y conversion. If you have a shape of y, okay, that's the shape of y. Y means this. This is a shape of y, or this is a shape of y. Okay, this is a shape of y. I mean, 3 resistors are connected on one point. Okay, you can change, you can convert this shape into another form. If you say this is point A and this is point B, this is point C, okay, A, B, C. You can replace this combination with this combination. Okay. And you will say, for example, this is RA and this is RB, this is RC. Okay, you reject 3 resistors, you insert another 3 resistors, and from the external points, externally from A, B, C, the other components cannot understand any change. Okay, the points A, B, C, you reject these components, you insert the other equivalent group, nothing in that circuit will change. Okay, they are equivalent, and this arrow is two-sided. Okay, if you have this shape, delta shape, this is called a Y shape or T shape. This is called a triangular shape or delta shape. Okay, this transform is both-sided. You can replace if it makes your job easy. And of course, you have to consider the relationships that the value of RA is equal to R1, R2 plus R2, R3 plus R1, R3 divided by R2. Okay, and similarly, RB is calculated like that. RB is equal to this, and similarly, RC is equal to this. Okay, so using these equations, you can transform from Y shape into delta shape, or you can transform in the back side, but you have to consider these relations. We have to calculate R1 from RA, RB, and RC. RA times RB divided by RA plus RB plus RC. Okay, and similarly you can calculate R2 like this, RC times RB. Okay, and similarly you can calculate R3 like that, RA times RC. Okay, so if you consider these equations, you can make a transform by this way. Your circuit will change. Look, this was your circuit. You reject this part, okay? You reject, and you replaced with the equivalent model. That's equal to the part I have rejected. You insert here. And now, can you see any combination, any special combination, parallel or serial combinations? Yes. Look, they are in parallel now. RA is parallel with R4. Similarly, they are in parallel. RC parallel with R5. Okay. So let's combine them. Let's redraw the circuits. This is RB. This is a combination. That's another combination. Okay, RA, R4, RA, R4. This is RC, R5. Now, as you see, these two are in series. Okay. This is RB. This is RA parallels R4 plus RC parallels with R5. And now they are in parallel. You can reduce the circuit in a form of one voltage source and one resistor. Okay, this is RB parallels with RA, R4 plus RC